At this point in the year, we have 2 units left, both of which are on circles.
Wow.
Although the second one will also include a reminder of a lot of stuff from algebra that you may have forgotten. So for those of you who are like, I'm better at algebra than I am at geometry, well, it'll be time to show it. And for those of you who aren't, well, it'll be time for you to remind you of some of the skills that you will need in Algebra 2. I can't make you guys happy. I really
I'm just
can't.
bad at math, Mr. Davis.
I don't think that.
I think I'm regressing.
Is that why you're so short? No, I'm just kidding.
Actually, I think I grew. I'm like 5'4".
All right, so a fair bit of vocabulary today. We're starting chapter 11 in your book, Lines That Intersect Circles. So some of them are lines, some of them are actually segments. A chord, just spelled like a chord in music, is a segment that has its endpoints on a circle.
I think we learned this in 5th grade.
Probably.
I love Mr. Chives. He's like my favorite.
I don't know that.
No disrespect.
Man!
Right in front of him.
Okay, a secant, on the other hand, is a line that intersects a circle at 2 points. So really the only difference between a secant and a chord is the secant is the whole line and the chord is just the segment from one point on a circle to another point on the circle. So every secant...
I did not mean to. It was in the bathroom.
Okay, fair enough, fair enough. Every secant contains a chord.
It was in the bathroom as well. I
He gave it to me.
And that was like on the hand sanitizer.
Yeah,
All right.
it was weird. It was
So
awful.
back to the lesson.
Yeah.
And then a tangent, and the tangent is actually probably one of the most important ones for this, is a line in the plane of the circle. Now you're like, what's that about the plane in the circle? I'll explain that in just a second. That intersects the circle in exactly 1 point. Okay, so what's this part about it being in the plane of the circle? Well, imagine this, if you will, that if you were like shooting an arrow at a target and the part of it was a circle, and the arrow went into the edge of the circle, right? Is that in the same plane that the circle's in?
Yeah.
The circle is on the target. Your arrow is
No.
going through the target. It's not in the same plane.
Are the planes the things that we learned earlier this
A
year?
plane is a flat surface that continues infinitely.
I didn't know.
Are they the same things that we did with the 3 points? Those types of planes?
If there are 3 points, yes. 3 points always contains a plane. 3 non-collinear points, at least.
Oh, that unit was not good. Uh-oh, here we go again.
But it has nothing to do with what we're doing here, really.
Oh.
You just need to know that a plane is a flat surface.
Okay.
Okay? This point where the tangent touches the circle is called the point of tangency.
That's crazy.
Original
I never would have
negative.
guessed. Whoa.
Okay? And with tangent, we'll use it both as a noun, that is a tangent, but we'll also use it, trying to think,
You go off.
as an adverb. That line is tangent. Or is that an adjective?
I don't think
That
something that's an
line
adjective.
I
is
never used
tangent. I think it's an adjective.
Metaphor.
A helping verb would be
Tangent line.
helping verb would be tangentially running or something.
Tangentially running.
That'd be an adjective.
Okay. So, real quick, identify everything in this.
Oh.
So every segment and every line gets an identification for this. Yes,
Well, we have to do angle measures for these types of things.
it's coming. Just wait. All right, so I'm going to start on the left. Segment QR,
Chord.
that's a chord. What about segment QP? We haven't talked about this, but you all know it. That is a radius.
How'd you know that?
Because you did radii of circles, a long time ago, like maybe even in elementary school.
Oh, I thought you were going to say like 5 minutes ago on the test.
No.
Yeah,
That's what I thought.
All right, what about segment PS?
A radius.
Radius.
And might as well, while we're at it, what's the other radius?
PTG.
PT. And what's the plural of radius?
Radii.
Radii.
English.
Because English borrowed words from lots of languages. In this case, Latin.
I knew that, guys. I used to take Latin.
Pardon?
I used to take Latin.
Really?
Yeah, at Providence, you have to take it from 3rd to 10th grade.
Wow.
I know. And then junior year, you can pick what you choose, but at that point, just learn, like, I don't know. I feel like you've already learned them.
Wait, do they make you
All right, so segment ST has two names.
Second?
No, segment ST is not a secant.
Oh,
It's a
My bad.
chord.
Oh, cool.
It's a chord.
Why is it a chord?
Okay, look at the definition of chord and then ask me that again. I double dog dare you.
Ooh.
That has an endpoint on the circle. TS? Oh, ST, we're not doing MT.
wait, would it still not work if it was MT?
MT?
MT.
There is no MT.
Why not?
M's not a point.
That's a lot.
It's a line.
It's the name of the line.
Oh.
All right, so what is the other name for this chord?
Diameter.
It's a diameter.
Yeah.
A diameter is a chord that contains the center of the circle. Yes, ma'am.
How many notes does something have to be a chord? Can a chord be 2 notes, or does it have to be?
It's a great question for your mom.
Oh,
I suppose you could have a 2-note chord, like open fifths. Does that count as a chord? Not something that I know.
Like 2 notes.
That was funny.
Thanks. So
Cecil the jokester.
line M, which is the same thing as line ST. What is that?
A second.
Secant.
Secant.
Yeah.
Some people say secant. I just don't like the way that sounds. Secant. And then line L
A tangent.
is a tangent. Okay, any questions about that?
You. Do you?
All right, moving on then.
You didn't do you.
It says
So-
minor segments.
We've talked about congruent objects pretty much all year. Remember, two objects are congruent if they're the same shape and the same size. Well, all circles are the same shape, but they're not all the same size.
They're all circular.
You could say that all circles are similar, and they'll be congruent if and only if they have congruent radii. Remember, again, back from first semester, if and only if means it has to work both directions. So if two circles have congruent radii, the circles are congruent. And if two circles are congruent, then they have congruent radii.
What's the name of that? We did those sentences.
That's a biconditional sentence.
Okay,
It works both directions. Yes.
So if you had the diameter and they were the same, they'd be equal because.
Right. If you have if the diameter from one to the other is congruent, then the radii have to be congruent as well.
And the area and the circumference are also like from their radii and diameter, which is.
Yeah. If two circles or any two objects are congruent, their areas have to be the same.
Okay.
Okay. We don't use this a lot, but you will see it occasionally. Concentric circles are circles in the same plane with the same center. A lot of times students leave off the part about it being in the same plane, but that's part of the definition of concentric. So again, back to the archery competition, the target is typically made of concentric circles. Pardon? Okay. And with that one, again, we're talking about words. The prefix con if it's indeed a prefix, sometimes it's not.
Con with.
With.
Spanish. Center.
Yeah. Center, ick. It's the same. With the same center is basically what that means. Okay?
That's crazy.
Yeah, there are crazier things.
Like what?
I don't know. Donald Trump was made president? That was pretty crazy.
What?
Yeah, at least it was unexpected.
Wait.
He said, what things are crazier than that? I was like, Trump won the presidency? That was pretty crazy. It was not predicted by the polls at all.
Yeah, it really wasn't.
I didn't know that.
You didn't know that?
Yeah, well, I mean,
That's why you gotta join the debate, Marion.
I didn't know that.
All right.
I would take you out.
so
Oh.
if we have two circles that intersect at exactly one point that are in the same plane, those are called tangent circles. And they can be internally tangent circles or externally tangent circles. Internally tangent circles always look to me almost like they're three-dimensional. Either looks like a pool ball, where they have the number on it, or an olive,
An eye.
or another way you can look at it is it's like looking through a megaphone or through a pipe.
Oh,
It does look like that, like a toilet roll too.
Yeah.
A log.
So looking through any kind of a cylinder that has,
Or like one of those beads.
Or
Kind of
one
like
of
that.
those.
oh yeah, like a bead,
Or one of those 8 balls that you shake up and then
the magic 8 ball.
and then you turn it around and it says.
Signs are unclear, yeah.
"I'll see you later."
It kind of looks like our biology project.
All right, so those are internally tangent circles, and these are externally tangent circles. All right, so here's one of the important things. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency.
That's a whole lot of.
But it's pretty easy to understand. And let me show you why. You don't need to write this down, but please watch for a moment. Let's say I have a circle,
That's like almost the same size, like exactly almost.
and let's say that I draw a line that is tangent, and then I draw this to the point of tangency. If it wasn't a right angle, and I'm going to draw one that's clearly not a right angle, is this blue line tangent to the circle?
No.
No. What kind of a line is it?
Chord. No, wait.
Secant.
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 Okay? So if it's not a right angle, then this line is not going to be tangent to the circle. And that's pretty much it for that theorem. We're going to use it a lot.
That's easy peasy. Lemon squeezy.
So let's take a look at these two examples.
They look like gnomes.
Muriel.
Okay.
What? Muriel, my favorite garden gnome.
Muriel has a thing for garden gnomes.
No, during swim team, she would always wear this red swim cap, and I would always tell her, because you put your hair in a bun before you put your swim cap on.
And so it kind of
Right
stood
here,
up.
So that she looked like a garden
No,
gnome.
most of us would put it like that.
Wait,
she would put her like right
on
here.
top, so it's like a point.
And so she's more streamlined.
Do you see the, Yes. the nose?
Yes?
Like the hat?
Yeah, I get it. I have an imagination.
Muriel, our favorite garden gnome.
All right. So in each diagram, KH and KD are tangent to circle C. Remember, that's how we name a circle, is by its center. It says find the measure of angle K. Well, we know that if that's a tangent, that both of these are going to be right angles. And what do the angles in a quadrilateral add up to? 360.
Is it a kite?
We'll get to that, but yes, this is going to be a kite.
Do we have to do the kite formula? Please no.
The kite formula. You mean for the area?
D1, D2.
half of d1 times d2.
Yes.
I don't think we'll be using that, but we will be using other things about a kite. So we know that these two add up already to 180, right? So how much is left for these two?
180.
180. So all we got to do is do 180 minus 138 is 42. This angle's 42. Now you could do all of them add up to 360, ladies. Let's see if we can concentrate on geometry for a little while. And then over here, the same thing is happening. We know that that's a right angle at D, and this is a right angle at H. Those add up to 180, so these two have to add up to 180. So that's 3x plus 7x is 180. So 10x is 180. I made it really easy. X is 18. So the measure of angle K is 3 times 18, which is what, 48 degrees? 54? Oh, what was I doing? Oh, I was doing 16 times 3 instead of 18. Thank you. Okay, questions about that? Okay, and this goes, yes?
Never mind.
Okay. This part goes to what Marion was talking about just a moment ago. If two segments are tangent to a circle from the same exterior point, then those segments are congruent. I had students who used to call this the ice cream cone theorem,
The Gnome Theorem.
if you want to call it that. Now, the question should be, do I have to take it away from you? Seriously? Come on. The question should be, well, they certainly look it, right? The question is, how do I know that those are? Again, don't worry about writing this down, but let's take a look. If I was to draw in a radius to both points of tangency, what do I know about the lengths of these two radii? Yeah, the two radii have to be congruent, right? And I know that that's a right angle, and that this is a right angle. And you're like, okay, well, that's nice. If I add in this segment, which is congruent to itself, why are these two triangles congruent to each other?
Side. Nope, that's not a thing.
So,
Hypotenuse leg.
there we go, hypotenuse leg. By hypotenuse leg, these two triangles are congruent to one another. So any of the corresponding parts are going to be congruent, which is why, again, as Marianne pointed out, this is going to be a kite. All right, so let's do an example problem here. HK and HG are both tangent to circle F. Find the length of HG. You're like, okay, well, I know that x over 4 is equal to x minus 6.3. There are many things that you could do at this point, but what do you think would probably would make the problem simplest in the long run?
Multiply each side by 4.
Yeah, get rid of the fractions. Multiply both sides by 4. So that's going to be x is equal to 4x minus 25.2. So that'll be negative 3x is equal to negative 25.2. So x is 8.4. And then we want to find the length of HG. So HG would be 8.4 over 4 is 2.1. Okay, any questions? Yes, ma'am.
I actually do have a question.
Yeah.
Oh wait, actually, I realized my answer the second time on the same question, but yeah.
Okay. Okay. Well, your assignment is in the book. And I don't even know what time this class lets out. 38. You got over 10 minutes. You should start on it.